Alright, this is the exponent properties video, part 1. Alright, this is called the base. The x in the expression is called the base. Okay, the base is the number or variable that is being multiplied. I'm just going to go up here. It's being multiplied repeatedly. Okay. The 2 in the picture is the exponent. Okay, the exponent is how many times the base is being multiplied. How many times the base is being multiplied. So for example, 2 to the 4th power, 2 is the base, 4 is the exponent, okay? And 2 to the 4th power is 2 times 2 times 2 times 2. 2 is the base, that's the number being multiplied repeatedly. The 4 is the exponent, that tells you how many times to multiply 2 by itself. Okay? So 2 times 2 times 2 times 2 is 16. Okay? Product of like basis. Product means to multiply. Product means to multiply. So when you are multiplying like bases, so that means that the base is the same. When you multiply like bases, to use the product of like bases, your basis must be the same variable, or number, which is why we say like, the like bases, okay, means the bases must be the same, okay. You simplify, or you simply add the exponents. Add the exponents. Add the exponents together of the like bases. So for example, x to the 4th times x to the 3rd. These are like bases because they're both x's. Since the bases match, I'm allowed to add 4 plus 3 would be x to the 7th. Alright, so for example, okay, when you have something like this, you multiply your coefficients. We are multiplying here. So you multiply your 2 and your 3 together. Those are your coefficients. That would be 6. And then you are going to add up all of your exponents. But they have to be like bases. So the x will go with the x. So we'll have 7 plus 4 would be x to the 11th. Okay, then you're going to add your y and your y. So we'd have 5 plus 3 would be y to the 8th. And that would be your answer. You multiply the coefficients and then you add up your like exponents of your like bases. Alright, for this example, again, multiply your coefficients. So 5 times 3 would be 15. Okay, and then add up your exponents. So x and x are like bases, so they can go together. So 4 plus 10 would be x to the 14th. So 15x to the 14th. Alright, quotient of like bases. Quotient means when you're dividing. So when you divide like bases. To use quotient of like bases, your bases must be the same variable or number, just like before when you multiply. To use like bases, the bases have to be alike. Okay, so that's the same rule here. So when you multiply with like bases, you add up the exponents. When you divide with like bases, you're going to be doing the opposite and subtract the exponents. Okay, when you multiply, you add. Well, dividing's the opposite, so when you divide, you do the opposite and subtract. So for example here, these are like bases, x to the fifth and x to the third. Okay, you would end up with an x as an answer, and 5 minus 3 is 2. Okay, you subtract from top to bottom. Alright, for example here, you are going to subtract your like bases, so you're going to put your c's together. 3 minus 2 is 1, and then put your x's together. 13 minus 3, or 3 minus 13. Okay? Since the bigger number is on the bottom, the bigger x, 13 minus 3 is 10, will go on the bottom. The reason for this is if you expand these out, c times c times c on top, and c times c on the bottom, and then your x's, we have 1, 2, 3 on top, and we have 13 on the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Almost ran out of room. Alright, when you do this, when you look at like dividing things and things crossing out, these c's will cross out. C divided by c is 1. C divided by c is 1. And so I'll have one c left on the top, which is where I put it in my answer. When I do the x's, these x's will cross out and be 1. These x's will cross out and be 1. These x's will cross out and be 1. So I'll have none left on the top, which is exactly what the answer looks like. I have a c left on top and nothing else. And then all these x's, all 10 of them, are left on the bottom. So when you subtract your exponents, wherever the biggest exponent is where you're going to put your answer. C was bigger on top, so the c was left on top. The x was bigger on bottom, so the x gets left on the bottom. Alright. So in this case, 11 minus 6 is 5, but since 11 is bigger on the bottom, x to the fifth will be left on the bottom. Since there's nothing left on the top, we still have to have a top. We have to have a numerator. You would put a 1. Again, if I expanded this out, 1, 2, 3, 4, 5, 6 on top, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I did that, and I don't recommend doing it, I recommend using the rule so it's much shorter and faster, but if you expand them out, okay, those cross out and divide to give you 1, these x's give you 1, these give you 1, 1, 1, 1. Okay, so on the top, this is, yeah, we cross them out, but it's really 1 times 1 times 1 times 1 times 1 times 1, which is 1. And on the bottom, we have x, 2, 3, 4, 5 of those. Okay, which is how we get the answer. Okay, so the subtracting rule is like a shortcut, an easier, faster way to do it. Okay, but if you're getting yourself confused, you can always write it out, expand it if you need to.